A taxi company charges $3.50 for the first bit of the trip and for the first 3 kilometers or part thereof, and then an additional 50 cents for every kilometer after that. Okay, so the kilometers are along the x-axis and the dollar amount is along the y-axis. So if it's $3.50 for the first 3 kilometers, well, before you really hop in, they're not going to be charging anything. So we're going to put an open circle right on 0 at $3.50, and then because that charge does not change, there's no slope to that for the first 3 kilometers. Try to draw that as horizontal as possible. And then after that, it's 50 cents per kilometer after that. So we've got an open circle here and a closed circle on 4 kilometers, an open circle at $4.50, closed circle at 5 kilometers, open circle at $5, closed circle at 6 kilometers, etc. So I'll just now, so this would continue depending on, of course, the length of the trip in the taxi. So we see that we get a piecewise function that looks like that, which is actually called a step function, as it looks like a set of stairs, of course. So this would be, and what we want to do is where the discontinuities are every kilometer after the initial 3 kilometers. And then if we want to write a function that models this situation, well, the cost, we know it's $3.50 if the distance driven is less than or equal to 3 kilometers. Now, I'll fill in the rest of this in a second. I'll just do some work down here. So for the first 3 kilometers, we're being charged $3.50. Then we're adding on to that, it's 0.5 kilometers for every kilometer. However, we can't recharge for all of the first initial 3 kilometers, so we need to subtract off those 3 that have already been charged. Okay, and then just algebraically we can just simplify that here. So we got 350 plus 0.5x minus 50, which gives us $2 plus 0.5x. Now that is under the condition that it is greater than 3 kilometers, okay? Okay, and that would be the function that would represent the situation of this step function of the taxi ride. Okay, and then the last little bit here, for what value of the constant c is this function, given by this, continuous at every number? Well, we have to make an assumption here. If we're going to make it continuous at every number, then at this kind of division point of x equals 2, then if it's going to be continuous, then that means that those 2 parts of this function have to be equal. So we'll just state that x plus c equals cx squared plus 1. And then, because x is 2, we just substitute 2 in. And then just continue working that out. Okay, so for this function to be continuous, c has to equal 1/3. Okay, well that would be it. See you tomorrow in class, and again, do the first 2 or 3 questions at home tonight to make sure you have a good understanding of this. Continue the rest at home. If you want to start working on the chapter review, here are the review questions, and there are a few notes regarding questions and answers to 1.6, which are stated here at the bottom of the page. Okay, see you in class.